to learn from one that we're having us here today, of course, the KW Intersections. My name is Dawar Aziz Ahmed. I am a co-op student currently at Deloitte, and I study computer science at Waterloo.
Hi, my name is Vikram. I am pursuing Masters in Computer Science from Waterloo, and now I'm also a co-op student at T-Space Deloitte.
Hi, I'm Lucas, and I'm a master's student in computer science from University of Waterloo, and also the co-op student at Deloitte T-Space.
So I'm sure everyone here has heard of the phrase natural language processing and NLP. It's one of the buzzwords going around these days, just like machine learning. So we thought it would be interesting to sort of talk about some common practices that people generally do, that companies these days, individuals these days are doing when it comes to NLP. And we're going to try to use some of these practices today. So we'll just give a quick introduction to what NLP is. We'll introduce you to our data set that we'll be using. We'll talk about some NLP concepts, some methods and algorithms that are commonly used these days, and we will apply these concepts to our data set and see the sort of results and analyses that we get out of that. So what is NLP, natural language processing? It's a branch of AI that deals with interpreting and manipulating human language, so essentially trying to understand the way human beings speak, the way I'm speaking to you right now, basically. It's basically a technology that we use to process large amounts of text, so these could be thousands, even millions of documents, large amounts of text that we are able to analyze very quickly, very efficiently with this set of tools and these algorithms that we have at our disposal. And using this, we can find common themes, we can group documents together based on their similarities. We can look for patterns in these documents, how they're produced, and maybe try to learn from that, try to generate those similar kind of documents. So our data set, it's the lost words of inmates on death row in Texas. I realize this is a bit of a morbid data set, but the reason we chose this was because it's free, it's available online. You can go to this website, Texas Department of Criminal Justice. You can go there, the list of statements is there. When we hear about this data set, we already have some preconceived notions about what this entails. We already have some ideas about what people say generally in this kind of situation. You think that they would ask for forgiveness, or they'd be really pissed off, or whatever. But we just thought it would be interesting to try to use NLP to actually find out what people generally say and what really is going on here.
Yeah, question. Are these written statements, or would these be spoken statements that have been transcribed by somebody?
These are spoken statements that have been transcribed, yeah. So what we did was we just used a Python library called Scrapey. Went to this website, scraped all of the last statements, and it ended up with about 500 statements from the last, I think, 40 years. So once we did that, we collected it, and this is what our data set looks like. About four of the data points. We got all the most important features, of course: age, country, date of execution, and the most important thing, of course, is the last statement.
So before jumping into NLP techniques and methods, we would first like to talk about what people would have done if they don't have natural language processing techniques. So as we have seen the dataset, which has some features like date, age, race, county. So if the dataset is very small, people can manually check the statement and can make some prediction. But if the dataset is really large, it's nearly impossible to do that on text. So what people would have done without NLP is they would have plotted some graph based on the county or the age range of the prisoners who have been executed. So they must have shown the trend which county has the most number of prisoners, or so which is the most common age range in which the people do the crime or get the punishment. Moreover, they would have seen the trend according to the date, which will show us what is the trend, how does the number of punishment increases over the year. As we can see, the most number of execution has been held from 1997 to 2009, and what's the trend like? how does it increase or decrease. But that's all what they would have done if we do not have any NLP techniques. But with NLP, we can analyze their last statement, we can find their trends. So the common NLP practices is like data pre-processing, in which we like prepare the data to feed that into the machine, clean the data, normalize it. Then, as we all know, machine does not understand text. We convert the data into numerical representation. After converting, then we group the data together based on some different algorithms, that is clustering, topic modeling, sentimental analysis, and emotion detection.
So as Vikram has mentioned that after we collect our data, the first step we need to do is do some preprocessing, basically clean the data. Because the original data has many noises like punctuations, and in another case maybe numbers or some special characters. We want to first get rid of that because it's not noisy information. We don't want that in our final data. And here I mentioned we list out two important steps. Firstly, to remove the stop words. Stop words referring to the words such as and, but, we, are, you, and I. So such a kind of words which don't really contain useful information. It just only connect the different parts of the word of the sentences. So first we remove all the words. Here's one example for we increase profits and reduce costs. After we remove the stop word like and, we get increased profits, reduced costs. And the next step usually people will do is called lemmatization. It converts the word to some base form, the root form. Such as here, increase will be converted as increase, and profits will be converted to profit. But this step may not be necessary in every task. It depends on what kind of task you want to do, what the result you want to achieve. So in our cases, these two steps are more necessary to us, but in some cases, other cases, people usually only remove the punctuation, remove numbers, remove the stop words, but they won't do lemmatization if possible. So Bacon also mentioned that after we get in the clean version of data, we want to do is to get the numerical representation. Because if we only keep the text data, what we can do with that data is quite limited. But if we can find some meaningful and good numerical presentation, then we can build more powerful tools out of the data set. And here, TF and TF-IDF are the most fundamental one to convert the data set. TF here refers to term frequency, and the idea is pretty simple, just counting how many times a word appears in each document and make it the document as a matrix represented by the times of the word. And TF-IDF here, IDF means inverse document frequency, and that is the formula to calculate. But the basic idea is you want to capture some words that may be frequent in only a few of the documents across all the documents, but may not appear in other documents. So those kind of words are more specific to some documents. They mean more typical and important to them. So we want to capture those TF-IDF words so it can give us distinguish between different types of documents inside the data set. And here is a simple code about how to using a library called scikit-learn in Python to get the TF and TF-IDF. And as you can see, scikit-learn actually is a really powerful library, and it can have many other functions like classification, regression, clustering, or many other machine learning algorithms that you can use it a lot. It's really simple to use and learn, and we will mention it later in our demo as well. And here, to get the TF and TF-IDF, first you need to create a new vectorizer and then just transform your text data, and the return value will be the numerical data. And here is what the TF and TF-IDF looks like. Every row will represent one document, and each column will represent the TF or TF-IDF value with corresponding to that word specifically.
So another way to represent text in a numerical way is word embeddings. So I'm sure a lot of you have heard of this before. Essentially, word embeddings are these really large vectors that represent each word. These vectors can have 500, 300 dimensions. And there's a lot of different libraries out there to produce word embeddings. Each of them produce different word embeddings. So you have Spacey, Glove, FastX, each of these. So word embeddings are produced by other machine learning models, and these can be trained on different data sets. So you could have a model trained on Wikipedia or Google News or a variety of data sources, but as there needs to be like a lot of text in order to produce word embeddings that make sense. But yeah, this is an example of what one word embedding might look like. It's huge. I mean, to us it doesn't really make sense, but this is actually something that a computer would understand. And it's also important to remember that even though the word embedding for words is unique, meaning is still preserved over here. So an interesting side effect is this would be in an example like this, where the word embedding, where the difference of the word embedding of Tokyo and Japan would be the same as the difference of the word embeddings of Berlin and Germany. So this is important that because we're converting text into numbers, we might be losing some meaning, but a lot of it is still preserved in this case. So that makes it very useful for us to use this in machine learning.
So as Dawar mentioned, we have to convert the text data to numerical representation, and now we have the numerical representation. How can we use these numerical vectors, or ways we can use? So one of the potential application of using them is in clustering. Moreover, as our data set has like large statements of inmates, which does not have any labels, so it comes under the category of unsupervised machine learning. So the thing is, like, if we use clustering, we can even group them together and define a label for them. So clustering is actually a task of grouping similar documents together, in which a same group will have similar documents and it will be different from other groups. So there are different methods of doing clustering, which is k-means and db-scan. So clustering approach in Python code is really easy. If we want to do clustering using k-mean, first we have to define the number of clusters, like how many clusters do we have to make. Let's suppose in this case we define k is equal to 6, and then we just pass the data to the k-mean library and then we predict. So one potential question arises here is how do we decide the number of clusters, or how do we come up with this number? So to find the optimum number of clusters, or to define the number of clusters, we have a method called elbow method. In elbow method, we plot the number of clusters according to with respect to the variance. Here variance can be quantified with many ways, but we are using the average with average sum of squares within the cluster, which means like we are calculating the distance of one document to the other document within same cluster. So how elbow method work is like to find the optimum number of clusters, we will define a range of clusters, let's suppose from 1 to 100. So the method will work like this. It will cluster all the documents within one cluster and calculate the variance. Since all the documents would be clustered in all the documents would be there in one cluster, so the variance would be very high. So then the method will do the number of clusters as 2 and will divide the documents into 2 different clusters, where each cluster will have similar documents. So as we keep on adding the k, we will reach a point where if we add another cluster, it does not change any variance, or it does not make any difference, which means like the similarity, like the average sum of squares in the clusters will remain same, or there will be very little change. To make it more clear, we also have an ideal graph of how elbow method looks. So in the x-axis we have number of clusters, and on the y-axis we have like average sum of the squares within the clusters. As we can see when we start the range, when the number of clusters is 1, the variance is so high, the average sum between the clusters is so high. But as we keep on increasing the number of clusters, as we move to 2 or 3, we see that the average sum between the clusters is decreasing. But as we move from 3 to 4, we can see that there is very minimal difference in the average sum of the squares. So there is very minimal difference within the variance. So this is where we find our optimal number of clusters. But when we apply this method to our data set, this is a graph what we get. So as we can see, like it doesn't give any elbow or some optimal number of clusters. So we experimented with different clusters from 3, 5, 7. For the purpose of this experiment, we are showing the results for the number of clusters using k as 3. So once the clustering is done, once we have clustered the document into different groups and each group has some similar documents, so next task is to how we can visualize those clusters. Since we showed you the word embedding vector, which has like 500 dimension vector, which is a 500 dimension vector, it's nearly impossible to visualize that. To visualize them or to reduce the dimension of the vector, we have two known methods, which is tsne and pca. For this data set, we are using tsne. We'll give our clusters to the tsne. It will do the dimensional reduction to 2D, and then we can plot the clusters, and we can do the visualization of the clusters. So as I mentioned, like we are using 3 for the number of clusters. You can see 3 different points: red, orange, green, and blue. To give some insights of the results, so when we actually visualize the results, so this smaller clusters we got this is the statement where the offender declined to make any statement, or where there is no statement given by the offender. So it means like the clustering algorithm has grouped the similar documents together. But for the orange and the green dots, so every statement talks about like family, love, and they also talk about sorry, pain, forgiveness, peace. So the statement shares a lot of similarity. These two clusters talk about, one cluster of the first cluster talk about sorry, pain, and the second cluster talk about the love, family. But the statement shares a lot of similarities. That's why they are grouped together. Yes.
So every point in that plot, does that represent an entire statement?
Yes.
Okay. And then how did you go from a single word vector to a vector representing the entire statement?
So in embedding, we had different embedding. One is like word embedding, the other is like document embedding.
Okay.
So we tried the both of the embeddings. In word embedding, we calculated the embedding vector of the word, and then we calculated the average of the whole sentence by adding the word vector.
Okay. So it's average word vectors.
Yeah.
For the whole document.
Yeah. Yes.
You have statements where the offender says that is charged unjustly, that's not guilty.
Yeah. Yes.
Because that's the issue, yeah, with the death penalty, yeah. That's why in Canada we don't have it, because there is this risk, and we have precedents where innocent people were accused
There are
unfairly.
some statements which are like 700 words long, and which the prisoner is trying to say like, reopen my case, I'm not guilty, something like that. But we have that statement.
We'll come back to that later.
So as Vikram said, I think Vikram forgot to mention that is the two clusters, we cannot really find a good distinguisher across the different document or last statement. So the next thing we did is so-called topic modeling. And actually topic modeling is another way of unsupervised clustering method. And what it does is to try to uncover the hidden data structure of the document. So-called, here it's called topics. So different from k-means or DB-scan, topic modeling can do what they can do is assign multiple labels to single documents. So it's not only A or B, but it can A, B, or both A and B, but different percentage. So topic modeling, what you're trying to do here is trying to find the relationship between text and the words in that text and different topics. And here are two common algorithms for topic modeling. One is so-called LDA, which is using the TF representation as an input, and the NMF is using the TF IDF as the input. And their methods are quite a little bit different, but the basic idea are quite similar. So I simplified it and represent it here using three types of probabilities. We can treat TF and the TF IDF as the probability of each word in different documents. And we're trying to break this breaking probability into two probabilities. One is the probability of each word in each topic, which means for topic A, how likely the people will mention using the word, some word or other words. And another probability is the probability of topic for each document, which means for certain document, how likely it belongs to topic A or topic B, or what percentage of the content belongs to topic A or topic B. And here is a simple code. Also, we use scikit-learn, and you just using 3 lines of code, you can build already train your topic models. And here you also same as before, you create a vectorizer, either the TF or TF idea, and then pass it and then state transform your text data then as a matrix, and then you pass it to an MF model or LDA model to train it. So to get the probability of word given topic, you can do is NLP model.components underscore. But if you transform the TF idea, the model will return the value as the probability of topic given the certain text. And after we train our topic model, we can get some interesting outputs and we'll ask actually. So here, each cloud, each block, it represents one topic. Then we found out 6 meaningful topics. Let's say first one, people usually talk about love, talk about care, and they also talk about God, love, Jesus, and or they thank to your family, they feel sorry for their family, feel sorry for their pain, or they want talking about hope, peace, and also some of them decline to make any statement. So by using topic models, we can find some common pieces across different documents. And here is a workload. Workload is only we get the topic top frequent word inside each topic, and we also get the importance or frequency of that word in that topic. But if we want to save the topic or the word in more detail, actually, we can use another library called PyLDA. Essentially, this library is designed for LDA method only, but we can also use it for an MF model as well. And this is one example from our case. As you can see, for the left-hand side, there are different cycles, and each cycle represents for one topic. And the larger the cycle is, means the more content across all documents belong to that topic. And on the right-hand side, you can see a list of words, and the bar shows basically you can see it just term frequency of that word across all the documents. And if you select one topic on the left-hand side, so you will highlight the words and ranking all the words related to that topic based on how important or how frequent that word is in that topic. As you can see, in topic 1, the most frequent word like family, love, thanks, sorry, like something like that. So if we want to say the words, how important is it to the topic, we can select the word. For example, here we select innocent, and we can see the cycle, the topic 5 become larger. It means innocent is most important in topic 5, but it's not that important in topic 2 or topic 3.
I have a question.
Yes?
Does it judge the importance to spell TF in a particular topic?
Say that again, sorry?
So for a particular word, does it judge the importance by the TF?
It depends on whether you are using LDA model or NLP model. As I said, LDA model will use the TF as input to train the topic model. but NMF will use TF-IDF as the training data for the model. So if this one is using LPA, then that one, the right side will represent the term frequency. But if you are doing TF-IDF, you basically display TF-IDF.
So another common practice is to analyze text data or to get some basic insights of text data is sentimental analysis and emotion detection. And I'm pretty sure all of us would be familiar with these two terms. So in sentimental analysis, it's like getting the feeling out of the text data. If we have any piece of text, what is the opinion behind the text? How does it feel? And by using the sentimental analysis, we can actually build an opinion of the public, like opinion of the inmates, how does they feel, what is their feeling behind the statements. And to do sentimental analysis, there are the common libraries are Stanford Code, NLP, NLTK, Scikit-learn, and Spacy. So when we do sentimental analysis, we actually label the data using 3 labels, whether it's positive, negative, or neutral. Or sometimes there are 2 more labels, which is very positive and very negative. So the basic naive approach to do sentimental analysis is, if we have a piece of text, we'll calculate the number of positive words and we'll also calculate the number of negative words. If the positive words are greater than negative words, then we label the sentence as positive. If the negative words are greater than positive words, then we label the sentence as negative, otherwise neutral. So this is very, very naive-based approach to the sentimental analysis, but there are also complex approaches in which you assign score to particular word and then you calculate the sum of the sentence. So once when we passed our data to the Stanford library, and so when we pass the data to the Stanford library, it first break the statement to the sentence level and then perform the sentimental analysis on it. So what we have obtained, the result is shows this graph. There are some sentences which show very positive, some positive, most of them are positive and negative, very less very negative, and some of them are neutral. So there are sentences which are like very positive and very negative, which has like really emotion or feeling behind them. To give you guys an example, so very positive sentence can be where people talking about love every one of them and always being loved by all my family, like more number of love. And positive can be take good care of yourself, and neutral can be anything. But there are some sentences which are very negative, but due to some concern, we try not to show that. And if someone wants to actually see that, you can scan this code right now or later, as you wish.
So sentiment analysis will generally tell you what is the sort of sentiment behind it, so whether it's positive or negative. But what if you want to go beyond that and actually find out what is the emotion being displayed inside this text? Someone can tell you this text has negative emotion, but how do you know whether that's anger or fear or sadness? So this is where something like emotion detection comes in. So what we did was we used an API called Parallel Dots, which is free out there. You can use it for your own benefit. And essentially this will classify the piece of text in these different categories, so anger, excitement, happiness, and such. So this is what we ended up with. This is pretty interesting, as it seems that like a lot of people are generally happy in their last few moments. So yeah, it's another way of analyzing your text essentially, is that you can understand like what is really going on in this piece of text. Like, for example, imagine you're a restaurant owner and you want to see the reviews that you're getting on your restaurant. So emotion detection would be really useful in that sense, where you can see like really why people are angry, like which reviews are angry, and what's going on in those kinds of situations. So here are just some examples of these different emotions. As you can see that the ones that for anger, sadness, and happiness, it sort of makes sense, whereas more abstract feelings, such as excited and fear, It's a more abstract sense of emotion behind these sort of pieces of text. I'll just give you a minute to go over some of these. Cool. So, in the end, so we covered a few common practices that generally people will do in NLP. As I said before, NLP is really powerful. Like we only had about 400 or 500 or so documents in this data set, but you can easily apply these methods to thousands or even millions of documents. In those situations, like clustering might give you more accurate answers as opposed to like the very fuzzy answers that we got here. But yeah, generally these practices are sort of built up to other more complex methods. So like word embeddings can then be used in text classification models. So you would get those classes from your clusters, and then you would classify the documents to your data set. You would use named entity recognition, which is another NLP, very important NLP concept in which you extract entities from your piece of text. So these could be things that fall into different categories, such as people, names, places, locations, organizations, things like that. And then of course there's text generation after that as well, where you are learning from the word embeddings that you're giving to your model. It learns these representations of the text, and then it can then produce word embeddings on the other side, which can then convert back into text as you wish. Awesome. So, thank you.
So you trained to, I mean, you were detecting emotions a couple of slides ago.
Yeah.
Do you know what data set that tool was trained on? I'm curious just from the perspective that it's obviously not conditioned on the fact that these are people on death row. So I'm curious if, you know, it's like it's trained on Twitter and it's trying to say if this was a tweet, this is the emotion. It's going to be different from adding context. I know there's no simple way of adding context today, but I'd be curious.
Yeah, actually that's a good point. I'm not sure what that data set is trained on, but I can get back to you.
Sounds good.
Did you find any kind of misclassification which you could see by doing it?
So what do you mean by
So for
misclassification?
instance, there was an example which you like for here,
Here?
but do you think it's depicting here or could it be?
So in my opinion, the reason why I feel like this was classified as fear is because, as you can see, like at the end it's like, oh Jesus, Lord, take me home, and then this goes on for a bit after that. It's more like take me home, take me home. So it's like I said, it's like a sort of abstract sort of feeling behind it.
Satisfied with kind of classification.
But yeah, from our experiments, we were pretty satisfied with what we were getting using this. Yeah.
Are these data used in any way to change people's behavior?
I haven't seen any examples like that. I know we came across this one paper where people were using this to sort of understand what is going on as well, where they were mainly just like reading the statements. But yeah, I don't see how this has been used to.
But it looks like the majority have a remorse for what they have done. So if you tell that to a potential offender, that look in what state you'll be, maybe he will not do what he's doing or
Yeah,
will do.
that's true. That's something like good that could come out of this. But I don't think I've seen anyone really do that. Yeah.
You mentioned that this is a data set from about 40 or 50 years.
Yeah.
Did you see any, like, did you interact across time, see the changes in language across time?
Yeah, and we actually didn't see any difference. So we tried doing different things. Like you saw the sort of data visualization we did. So instead of using the colors that we got from clustering, we tried doing it based on, say, race or age, or the date that they were convicted, or how long they spent in prison before they were executed. And there was like absolutely no relationship. It seems like it's completely dependent on the person. Yeah.
So if you were to do, say, like the clustering, training clustering, then you had it in, say, 4 categories, and then you did topic analysis for each of the categories, would you think there'd be some kind of insight that way?
I think that could, so do topic modeling just on a particular project?
Yeah. Just to see if like different topics kind of reflect on answers.
And then, yeah, and then it would really depend on your perception of that. Like if those topics made sense, then that would be really good. That would give you even more insight, but it really depends on the result that you get out of that.
I guess it doesn't how many topics there are.
Yeah. But that's like another step. Like there's always these intersections between these different
There's
methods.
always more you can-
Yeah, absolutely. Absolutely. That makes sense. Yeah.
Is there any loss in context, in the contextual information when you convert like data from one representation to another? Like for example, from what I saw, TF-IDF, the first thing that you spoke about, did not really have any, it did not take the semantic of the words into account. Yeah, where the two different words that mean the same thing could be misclassified into like completely different things.
Yeah, actually, yeah, sorry.
Yeah, and the one after that where he showed that Japan and Tokyo are classified so that there is some kind of similarity measure between them. They may have been appearing in completely different contexts in a sentence. And are there any representations which, instead of taking a word or a sentence, they can also take like common phrases, idioms, where when you say that, the words that appear are very different. Individual words are very different from what they collectively mean.
Yeah, I think actually you made a good point here. So in our, when we're talking about word embedding, we only show maybe using glove or most simple word toolback as an example, but nowadays there are more advanced word embedding models such as BERT or GPT. We didn't mention that here because it's more like a common or basic practice, but when you have using the BERT or GPT word embedding models, it can take the context, like you said, the word embedding is contextual. So you can take the context into account. So it can distinguish the relationship between different words, and maybe same word has different meaning. So in this context, what does the word really mean here? So those advanced models can take that.
Did you find with this analysis that people revealed the reason they did the offense? Because there are countries, I think Denmark has no prisons, so they have like better NLP methods to convince people not to offend?
Yeah, I suppose so. I mean, like none of these statements, in none of these statements, like, did the person really talk about what they did? Like in one example you have where he said, I stole 2 lives, but this was very rare. So generally what we saw was that people were just like, take care of yourself, your family, like, I love you guys, things like that. So generally just like happy or positive emotions behind it, whereas they didn't really talk about the crime that they committed, basically.
Or moreover, they talk about like the sorry or forgive me, God bless my soul, something like that, wishing for themselves and their family and the forgiveness from the family of the suspect. But yeah, they don't talk about their crime very rarely. They don't have that. Yeah, yes?
Can you go back to the bearings versus
Sorry, which one?
the bearings versus
Oh.
If you don't see any algo here, does it say something about constraining? Wouldn't you expect this kind of plot for a range of data?
So this can also arise when like your documents are just like, there's not really like clear distinctions, right? So like we said, like we saw these different topics of like family or like God or such things like that. But the truth is like those topics, like more than one topic can be present in a particular statement. So generally what this really tells us is that we cannot really separate this data set into distinct features where we get like one cluster is talking about this as opposed to one cluster is talking about this. It's really just like sort of overlapping in a way.
Actually, that also makes sense after we doing topic modeling and we can find interesting or meaningful topics. Because the classing here is only single label. So you can only classify each document in one specific label. But for topic modeling, you can multiply, assign multiple labels to one document to make more sense.
Oh, yeah.
So how many positive emotions can we detect? Does it depend on the library that's being used?
Yeah, so the maximum I have seen is like 7, but they are like paid libraries. Paid library. In this library there are 6. The one which did not get classified here was like board. There was also a emotion named board, but we didn't have any example of that. So like the maximum this library can go up to is 6, but I have seen maximum of 7, in which they also have discussed as one of the features and some others. And shy also. But it can be 7 or 8.
So why did Deloitte ask you to do this?
They didn't.
They did. Maybe I asked the gentleman say next.
Yeah.
Which is not the guy Please don't tell them. I could keep our job. Awesome. Thank you guys.
Can I ask a final
Yeah.
question? How do you find these interesting data sets? How do you know?
Ask the gentleman.
The guy laughing.
Like, is there a method which you can follow to like
So how do we find the data set? Or
topic or data? I mean, yeah.
How did we came across this data?
to be honest, we were just looking around for data sets that would probably be interesting to use. I think if you just, like, I'm sure you know about Kaggle. So this data set exists on Kaggle. So we were just like Googling there and we saw, okay, wow, inmates on death row. That's kind of cool.
There's Google based stuff. That's sort of, it's an aggregator. It's a search for data sets. Oh, that you mean the one given by the government?
Yeah. And we decided to choose this data set because there were not much work done on this and it's very
People
uncommon.
that usually use movie reviews,
Yeah.
Twitter data,
And
Google News.
that's very common. So
Thank you. And